Objective 4 takes those graphs that we've become very familiar with, and it now reflects them across either the x or the y axis. Now the equation is going to tell you what to do, so this should be in your notes. If you were given any function, and then such as f of x, and then you were asked what is f of negative x, well, that would simply be the graph of that function reflected across the y-axis. What if you were asked for negative f of x? That would be the graph of the reflection of that function across the x-axis. So these two instructions are really important. But before you can reflect something, you have to know what are you dealing with in the first place. So we're going to start off with a function f of x equals 1/3 absolute value x plus 2 minus 4. Now, from the characteristics of this graph, we know it's going to be a v, and we know it's going to be an upward v because the slope is positive 1/3. But how is it different from the parent graph? Well, the equation tells us it's been shifted 2 units to the left and 4 units down. So the key point is no longer at 0, 0. It has gone 2 units to the left and 4 units down. Now the slope is 1/3, up 1 over 3, up 1 over 3, and that's what we've got right there. We have 3 key points on this graph. Now the next thing is describe and graph f of negative x. Well, let's describe it first. What is happening to this function? It's going to be reflected across the y-axis. Now, that's the description. Now let's graph it. We've got our 3 key points. Where would those points be if they flipped across the y-axis? The y-axis is the vertical axis. So let's take the vertex first. Where would the vertex be? Well, it takes 2 steps to get back to the y-axis. So I'm going to take 2 more steps on the other side. And there we are, right there. Now on this one, I only have to take 1 step to get to the y-axis. So I'm going to take 1 step that way. Now this one, I've got to take 1, 2, 3, 4, 5 steps to get to the y-axis. So I'm going to go 5 steps the other way, and it's going to get me about right there. And so there we are. The original function is the one in black, f of x. And the reflected function, f of negative x, is the one in blue. Now let's talk about the domain and the range of the original function. The original function's in black. The domain goes all the way to the left, all the way to the right, so negative infinity to positive infinity. Now, this absolute value graph has a minimum point. The lowest point is -4, so the range starts at -4, but it goes up forever and ever and ever, so the high side is positive infinity. Now, if you look at the reflected function, which is right here, it's pretty much the exact same thing. It goes to the left forever, it goes to the right forever, so the domain is negative infinity to positive infinity. And the range, the low point, is still -4, and it's still an up absolute value, so therefore it really has no high point because it goes forever and ever and ever. Second example we're going to work with regarding reflections is going to be an exponential growth function, as you can see simply by the equation. F of x equals 2 raised to the x minus 2 minus 5. Describe the translation from the parent function. Well, the x minus 2 part of the equation is pushing that key point 2 units to the right, and the minus 5 is dropping that key point 5 units down. Now, since it is an exponential function, remember it's going to have an asymptote, and that asymptote that usually sits there right on the x-axis, it's going to drop 5 as well. So that might as well be the first thing we graph is the new asymptote. Down 1, down 2, down 3, down 4, down 5. So here's where the new asymptote lies. Now we might as well worry about the key point. The key point on the parent function is 0, 1, but we know how it's been moved. It's been moved 2 to the right and 5 down. So here's that new key point. And if you want to figure out where a couple more points are, just make an XY table. And let's go from x equals 2 to x equals 3. Let's see where the next point is. So when x equals 3, go back to the equation. 3 minus 2 is 1. 2 to the first power is 2. And 2 minus 5 is negative 3. So there is a point on this graph that's 3, negative 3. 1, 2, 3, negative 1, negative 2, negative 3. Let's just get one more point as well. So x equals 4. So when x equals 4, plug it in. 4 minus 2 is 2. 2 squared is 4. And then 4 minus 5 is negative 1. So 1, 2, 3, 4, negative 1 is another point. So that gives us enough to work with as far as this exponential growth graph is concerned. We know it does something like that. Now let's go and worry about the domain and range right now of the original function. So to the left forever, to the right forever. So domain is negative infinity to positive infinity. Now the range. The lowest point is, the asymptote, which is at y equals negative 5. But remember, this graph never touches that negative 5 line. So the lowest point is an open negative 5 because it never touches it. If it had touched it, it would be closed, but it doesn't. So it's an open negative 5. And then the high part of the range is infinity because this goes up forever and ever. Now on to the new stuff for this lesson. Well, if this is f of x, what is negative f of x? Well, you got to figure out, what does negative f of x instruct you to do? Well, it says reflect across the x-axis. So that's kind of the reason why we had to not only find where the key point was now, but it's why we added a couple more points in the graph, because we're going to take those 3 graphs, those 3 points, and we're going to reflect them across the x-axis. But there's one other thing that reflects across the x-axis as well, and that is the asymptote. So the asymptote is 5 units down from the x-axis, so the reflection would be 5 units above. 1, 2, 3, 4, 5. So here's the reflected asymptote. Now let's look at what happens with these key points. That point right there, remember we're reflecting across the x-axis, so 1, 2, 3, 4 steps to get to the x-axis. So let's go 4 steps on the other side, and we get right there. 3 steps to the x-axis, 3 steps on the other side gets us right there. 1 step to the x-axis, 1 step on the other side gets us right there. So what is this graph doing? Well, it's doing this. It's doing that. So let's look at the domain and the range of that graph. Well, the domain is still the same, all the way to the left, all the way to the right, opening to the left and the right forever and ever and ever. So negative infinity to positive infinity. Now the range. The range has no low value at all because it keeps opening down and down and down. So negative infinity, but it does now have a high point. The asymptote is at positive 5, and the graph never touches that asymptote. So it's positive 5 with an open bracket. Here's an example that'll help you out with the back side of worksheet 4. Now, it kind of looks ugly, but it really isn't. We're going to take this graph as it's drawn, and we're going to define it as g of x. Notice we aren't worrying about what is the equation that produced this graph. So this is g of x. So regarding g of x, find the domain and the range. Well, domain goes left and right. The furthest left x is negative 2. That's kind of where the graph begins. And yes, we do use negative 2. And it doesn't go to the right forever and ever and ever. It ends at x equals positive 7. And yes, we use positive 7. Now the range. The lowest number to the highest number. The lowest point on this graph is negative 5. And the highest point on this graph is positive 5. Now, if this is g of x, what would g of x plus 3 and then minus 2 look like? Well, this is where our knowledge of translations comes in. What is happening to the original g of x function? It's being shifted 3 units to the left and 2 units down. So if you look at these 1, 2, 3, kind of 4 marked points that I used to create this graph, we're going to do this. We're going to shift every one of them 3 units to the left and 2 units down. So what started at negative 2, 5 is going to go 3 more units to the left, which would be at negative 5, and then come down 2 units, which would be at positive 3. So negative 5, positive 3. Now this point that's at 1, negative 5, it's going to go 3 units to the left, so it's going to be at negative 2, and it's going to go down 2 more units, so it's going to be at negative 7. So negative 2, negative 7. And a straight line joins those 2 points. Now let's move on to the next point. The next point is 3, 0. Well, if I go 3 units to the left and 2 units down, that gets me at 0, negative 2. So that's the new point. 0, -2. And what joins those 2 points looks like maybe the left-hand side of a down parabola. No? Like this. And now we go to the last point. That last point is 7, 1. Well, it goes 3 units to the left, so that'll put me at x equals 4. And it goes 2 units down, so that'll take me to -1. So 4, -1. And those 2 points are joined with a straight line again. So there's the new equation. Or sorry, there's the new graph. Now, domain and range. Still left to right. Okay, what's the furthest left point? 1, 2, 3, 4, 5. -5. What's the furthest right point? 1, 2, 3, 4. The range, the low to high. What's the lowest point? -1, 2, 3, 4, 5, 6, 7. And what's the highest point? Right up there, 1, 2, 3. And that takes you to the end of worksheet 4.